we get cotangent squared x plus 3 cotangent x. You subtract your 1, so equals 0. Okay, and then we try what multiplies to a -1 and adds to positive 3. And we have a problem. Okay, so think about like quadratic formula. When you had a quadratic that you couldn't solve, we could do quadratic formula in algebra, right? If you had something like x squared plus 3x minus 1, you'd say x equals the opposite of b plus or minus the square root. You guys remember this? Let me write down the formula. B squared minus 4ac all over 2a. Now that's what the variable equals. My variable here is like this cotangent x. So cotangent x equals the opposite of 3 plus or minus the square root of 3 squared minus 4 times a times c. -3 plus or minus square root. 9 plus 4 is 13 over 2. Okay. Now, obviously, we don't have memorized when cotangent is this. So first, let's convert that into a decimal. So if I did -3 plus the square root of 13 divided by 2, that is 0.30278. When I do the opposite of 3 minus radical 13 over 2. Is everybody with me here? So all I did was plug this in. The positive gave me that, the negative gave me this decimal. Quadrants. Let's finish solving this one over here. When is cotangent positive? For our reference angle, we were in degrees, so switch over into degree mode and do, okay. We don't have a cotangent button. So we figure out how to type this in. This means tangent is the reciprocal. I threw every ugly piece into this I can. I think the cofunctions are the hardest to work with. The reciprocal functions, I threw in a quadratic formula, just trying to give you all the ugliness at once. So we have to do tangent inverse of 1 over 0.30278. And let's just go to a couple decimals on this. So, my x could equal, in quadrant 1, your angle is your reference angle. In quadrant 3, what would we do? Mm-hmm. Have I lost anybody there?
Why do we add 180?
To get the quadrant 3 answer. This one is a negative. And what quadrants is cotangent negative? To get our reference angle, right, we have to think that means tangent is 1 over, but we never do the negative. So we do tangent inverse of 1 over positive 3.30278. Okay, and we could keep more decimals if we wanted. I'm trying to make it a little bit nicer, so I'm just keeping a couple. But we could certainly do 3 or 4 if I asked. How would I put that reference angle in quadrant 2? It's 180 minus 16.85. 163.15. And in quadrant 4?
360 minus
360 minus the reference angle. And how could I check each of these if I wanted to?
Yep.
put them back into the original. Those go in for your x. So you could put it in and see if it works. We will have a slight rounding error, but they should still be very, very close. All right. If I said all possible solutions, what would we have to do on the end of each?
Plus K, 360.
Plus 360k, where k is an integer. All right, so that is as ugly as I can give you. We had to do quadratic formula because it didn't factor. We had a lot of answers. We had to use the reciprocals, put them in our calculator. They weren't nice ones from the unit circle. All the ugliness. Any questions on that one? Let's solve this one. This one is already equal to 0. So we need to start by greatest common factor. What can I take out of both? If I take out my cosecant theta, I'm left with tangent theta minus radical 3 equals 0. So if two things multiply equals 0, you set them equal to 0. Cosecant is a reciprocal of sine. So this means sine is 1 over 0 or undefined. Can sine be undefined? No. So that one's not possible. Sine is always something between -1 and 1. This one says tangent is equal to a positive radical 3. We can do this. In what quadrants is tangent positive?
60.
Reference angle, we are in, did I tell you, radians? So tangent is radical 3 at 60 degrees, which is pi over 3. So pi over 3 in quadrant 1 is still pi over 3. In quadrant 3, we know the top is 1 higher, so that would be 4 pi over 3. Yeah.
So does that mean cosecant, cotangent, and
Secant?
secant, they can never equal 0?
Secant and cosecant cannot, because they're the reciprocal of sine and cosine.
So we can't have the reciprocal of 0.
Mhm.
But cotangent is...
Can. Because it's, remember, tangent and cotangent can be anything.
Okay, so then cotangent would just be as long as the whatever's on the...
Yeah.
How do we know which equations we're using, like the quadrants, if they're actually positive, and that like quadrant 1, quadrant 2, or quadrant 1, quadrant 4?
Thinking all students take calculus back from the beginning. So asking when tangent is positive. So it's all in one, and tangent and quadrant 3. So that's separate from the inverse thing where we had one positive and one negative. Is that what you were kind of getting at? So that leads me into, I wanted to do a couple review problems. These are not on today's homework. These are reviews from the previous section. And we're going to do some more tomorrow. But since it came up, let's go ahead and do a couple. If I asked you to find each of the following. So if I said y equals sine inverse and let's do these in radians. Okay, you want to do degrees?
I knew it was gonna be radians. I don't care.
Okay.
Radians always just sound so much more like scary.
Okay, so these, they are different. We are not dealing with every time sine or cosine is positive or negative. Okay, when I see that sine inverse at the beginning, that tells me my quadrants are limited. Sine inverse can only have an answer in which two quadrants?
One and two.
Quadrant 1 and quadrant 4. So if the original has the inverse, that's how I know I'm limited. What I'm asking you is, when does radial sine equal a negative 1/2? If it's negative, in which of those quadrants would it be?
4.
Okay, let's do reference angle. When is sine 1/2? 30 degrees. So 30 degrees in quadrant 4.
We're in
Yeah, we can do. Yeah. So you could say 330 if you did degrees. If you did radians, 30 degrees is pi over 6, so it would be 11 pi over 6. So if I didn't specify my directions, you could give either. Alright, so if it starts with an inverse, you only get one answer. So arc cosine. That is the same thing as saying cosine inverse. In what quadrants can cosine inverse exist?
1 and 2.
So this means cosine of y equals radical 3 over 2. Since it's a positive, which quadrant are we in?
1.
When is cosine radical 3 over 2?
60 or 30 degrees now.
Cosine of 30 is radical 3 over 2. So you could say 30 degrees. Or if you did radians, that's pi over 6. Alright, C, arctan, which quadrants?
1 and 4.
Everything is in 1, and tangent goes
Plus
with
zero.
sine. 1 and 4. So this means tangent of some angle is a negative radical 3. We're finding the angle. If it's a negative, which of those quadrants are we in?
4.
Alright, reference angle. When is tangent radical 3?
60 degrees. 60. Is it?
Because
Am I
it's
the wrong
square
way?
root of
I'm
top
the wrong
over
way
square root
over
of bottom. So, no, it's 60.
Oh, okay. Okay.
So radical 3 over radical 1 is radical 3, so 60 degrees. So in quadrant 4, 360 minus 60 is 300. Or if you did radians, that would be 5 pi over 3. Alright, last one. Cosecant inverse. That does what sine does, so which quadrants?
1 and 4. But I don't think it can ever be.
If it's a negative, which quadrant are we in?
4.
So cosecant we may not be as familiar with, but we know that's reciprocal of sine. So that means sine is 1 over the square root of 2, or negative radical 2 over 2.
Oh, okay. 45 degrees.
So that's 45 degrees. So
315.
in quadrant 4, 360 minus 45 is 315. Or if I did radians,
7.
7 pi over 4. If you have a filled out unit circle, you know you're just looking on the unit circle in quadrant 4, when is my y? Radical 2.
What quadrant 3 is still left out?
Yes, quadrant 3 we never use. We don't like it.
Oh, that's not very nice.
Okay, so this is some review. Tomorrow we are going to take another day and do sections 1 and 2 and review them both some more. But these book problems are due tomorrow. So the ones that I gave you a couple days ago, you now need to finish.
Yesterday.
Yeah. Well, I gave you part of them the day before yesterday.
Did you?
I think so. Maybe.